Welcome to my video course on mastering ERTMS/ETCS signaling systems. Today, we are tackling a major paradigm shift in modern railway technology by understanding ETCS Level 2. Now, if you're already familiar with traditional railway signaling, you know that keeping high-speed trains safely separated has, historically relied on a massive amount of physical trackside infrastructure. But as our need for faster, more frequent, and highly interoperable train travel has exploded, that traditional approach has really hit its limits. ETCS Level 2 changes the game entirely. It essentially pulls the intelligence right off the tracks and puts it into central computers and the train's own cabin. So, we're going to break down exactly how this continuous radio-based system actually works, how it guarantees safety at speeds pushing 300 kilometers per hour, and why it's absolutely the backbone of today's high-speed rail networks.
Here is our game plan for today. We've got 4 core technical concepts to demystify. First, we'll look at the shift to continuous communication. Second, the radio block center. Third, GSMR, which is the vital link. And fourth, movement authority updates. Let's just dive right in.
All right, part 1, the shift to continuous communication. So, under ETCS Level 1, we relied heavily on spot transmission. Picture a train moving down a track. To get its instructions, its permission to proceed or its speed limits, it had to physically pass over a trackside beacon called a Eurobalise. That balise sends a quick burst of data, a telegram, up to the train. But in between those balises, the train is essentially just coasting on the last set of instructions it received. It's very much a spot transmission or semi-spot system. But ETCS Level 2, that introduces a massive paradigm shift. Instead of waiting to run over a physical beacon just to get an update, Level 2 provides a continuous stream of data to the train via a digital radio network. The physical trackside signals are virtually eliminated. The train doesn't have to wait for a specific physical location to know if the track miles ahead is clear. It is constantly, continuously being updated in real time. Moving right along to Section 2, the Radio Block Center. I want you to think of the Radio Block Center, or RBC, as a highly secure automated air traffic controller, but exclusively for a specific sector of railway track. It is literally the absolute heart, the safe central computer of the ETCS Level 2 trackside equipment. See, the RBC has a complete, perfect database of the track layout it governs. It knows exactly where the switches are, where the curves are, and even the gradients of the track. But more importantly, it continuously receives information from the interlocking systems about route occupancy and route states. Based on all this real-time data, the RBC calculates safe separation distances and sends what we call movement authorities out to every single train operating within its jurisdiction. It is the ultimate authority, making absolutely sure no two trains ever occupy the same space. Now here is a really fascinating constraint: 70 kilometers. An RBC doesn't control an entire country's railway network. That would be a huge single point of failure and, honestly, just way too much data to process. So instead, an RBC typically governs an area of responsibility of about 70 kilometers. But think about it. Trains, especially high-speed ones, cover 70 kilometers incredibly quickly. So what happens when a train leaves one RBC's area and enters another? Well, the system utilizes this highly coordinated handover process. Before the train even reaches the border, the handing over RBC starts communicating directly with the accepting RBC. They smoothly and securely pass the train's data, its identification, and its supervision responsibilities between each other. For the driver sitting in the cab, this complex digital handshake is completely seamless. The train just continues at maximum speed without any loss of performance whatsoever. Which brings us nicely to Section 3, GSMR, the vital link. So, to actually allow communication between these speeding trains and the stationary radio block center, the entire system relies on GSM-R. This is an international wireless standard specifically developed for railway communications. It is essentially a private VIP cellular network exclusively for trains. Instead of competing for bandwidth with everybody's public mobile phones, GSMR transmits on a dedicated frequency band, specifically in the 900 megahertz range, reserved entirely for railway operations in Europe. This provides a highly secure, continuous link. The RBC feeds its instructions into a gateway, which pushes that data through switching centers, out to the trackside radio towers, and then directly into the antenna of the train's onboard unit. It's this dedicated radio link that makes the continuous data stream of ETCS Level 2 physically possible in the first place. And finally, Section 4, Movement Authority Updates. The single most important piece of data flowing through this entire system is the movement authority, or MA. Simply put, it's the strict digital permission sent from the trackside to the train, allowing it to safely cross specific block sections of the track. Without a valid movement authority, a train literally cannot proceed. If a train somehow attempts to move past the limit of its movement authority, the onboard computer will automatically intervene and slam on the emergency brakes. It is the ultimate digital safeguard. So, how exactly is this movement authority generated and maintained? Well, it's a continuous dynamic feedback loop consisting of 3 main steps. Step 1. The train automatically figures out exactly where it is using onboard sensors and passive trackside balises. Now, in Level 2, those balises act just like electronic milestones for location calibration rather than instruction senders. The train then reports its exact position, its speed, and its direction of travel back to the RBC via the GSM-R network at regular intervals. Step 2. The RBC receives this position report. It looks at the track ahead, checks the interlocking data to make sure the route is locked and free of other trains, and calculates the safe distance that train can travel. Step 3. The RBC transmits a fresh movement authority back to the train via GSMR along with specific track data like gradients and speed limits. Because this loop happens continuously, the train always has an up-to-the-second picture of the track miles ahead of it.
So the absolutely crucial point here is understanding the real-world impact of all this technology. By integrating the RBC, GSMR, and these continuous movement authority updates, we completely change how railways operate. First, physical trackside signals are completely replaced by the driver-machine interface, or DMI, right inside the cab. The driver is looking at a screen, not squinting out the window to know their permissions. Second, the onboard computer is dynamically monitoring the train's speed against the most restrictive speed profile. If the driver goes even slightly too fast for the braking curve required to stop at the end of their movement authority, the train will just brake itself. And finally, the big takeaway, because the system is so incredibly precise and continuous, trains no longer have to rely on rigid, worst-case scenario physical block distances. They can run much closer together safely. Moving to this cab signaling ATP system enables up to a 40% increase in line capacity on existing infrastructure. We can move a lot more trains a lot faster with significantly higher safety.
But, engineering always pushes forward. As rail traffic keeps increasing, a connection-oriented network like GSMR can actually become a bottleneck, limiting the number of simultaneous data connections in heavily congested areas. Plus, ETCS Level 2 still relies on fixed block sections for track release, which brings up a really exciting question for us to ponder. What happens when the GSMR network finally reaches its absolute data limits, and how will a future ETCS Level 3 moving block system actually solve this? Thanks, we can see you next video.